This video is a quick explanation of Hooke's law, which is the force that springs exert. So the spring force is a restorative force. It's something we call a restorative force. It will always push or pull towards a rest or a neutral position. So if you have a spring and you stretch it, it's going to pull back towards where it started. If you compress it, it's going to push back to where it started. An ideal spring is one that exerts a force that increases linearly. So if I pull it twice as far, it pulls back twice as hard. So the farther I stretch it, the harder it pulls linearly. So if I pull it 1 meter, it's going to give some force. If I pull it 2 meters, it's going to give twice that amount of force. If I pull it 5 meters, it's going to do 5 times the amount of force. This is sometimes known as Hooke's law, and it's just that Fs is equal to negative K times delta X. So this K is the spring constant. And this is the displacement from neutral. Or you can think about it as the stretch or compress. And you'll notice it's negative because that means they'll act opposite. So if I push it, if I have a spring and I push it in, the force, like my X change, is going to be to the left. This negative makes the force push back to the right. Conversely, if I stretched it, then the negative would mean that the force pulls back to the left. So this is just how far you've stretched it or compressed it. So you need to know the original length and you need to know the new length. And compare those two, subtract them, and that will give you your displacement. Multiply by the spring constant, and that will give you Fs. You will always be given the spring constant or asked to solve for the spring constant. The way we find these is we just take a spring and we apply known forces to it. We stretch it a certain amount, and then we know that that's how, like, we stretch it with a certain amount of force, and we know that that's how much force the spring is exerting back because it's not moving. And then we just measure how far it's stretched, and then that tells us, if we know how hard it's pulling and we know how far it's stretched, we can use that to solve for K. Okay, so an example, a spring stretches 10 centimeters from its resting position when a force of 25 newtons applied. What is its K? So if I have the spring and then I have the spring stretched, if this stretch right here, our delta X is equal to 10 centimeters, then we know that our spring, like the end of the spring here, feels a backwards pull of F spring is equal to negative 25 newtons. And we know that the force from the pull is equal to positive 25 newtons. And again, we need that negative here so that our equation will end up working out. Fs is equal to negative K times delta X. So our K is equal to negative Fs over delta X. K is equal to 25 newtons over 10 centimeters. So we could write it as 2.5 newtons per centimeter. That would be acceptable. That is a spring constant. More often, you'll see it as 0.025 newtons per meter, just converting that centimeters into meters. So this is the idea of springs and spring constants. Let me know what questions you have.